Yo, what is up guys? Welcome back to another video. Today we're going to be checking out what would happen if the sun turned into a supernova using the explosion tool in the universe sandbox squared. So let's get right into it by slowing down the days / hours / minutes per second down to seconds. And let's start the simulation. So we'll start off a bit faster just so it reaches Mercury and the outer planets first. And by now no changes taking place apart from Mercury's temperature increasing and even Venus's. Earth not so much at the moment. So it's actually only a few minutes after the sun turns into a supernova, and really Mercury is the first one to be affected. However, Venus has reached 600 degrees already. What's this mean? It means that energy is traveling fast, but since Venus has a higher atmosphere, the gases can build up, creating heat faster. However, Mercury has no atmosphere, so really the main energy has to reach Mercury before getting so hot. And at the moment, Mercury is at 48,000 degrees Celsius. That's hot. That is hotter than the sun. And by now, Mercury is evaporating and Mercury is completely destroyed. Has been completely destroyed. Venus has reached the 800 mark. Just about to hit 1,000, I'm pretty sure. 900. Not too bad, but it's hot. As for Earth, no change as of yet. And we should see a huge jump up in temperature for Venus very soon. Mercury has actually reached a scorching 6 million degrees Celsius. What? That is burning, scorching, oh my god. Can't even believe it, can you? So now we can see Venus is actually increasing and decreasing in temperature all the time. It's like, why are you switching? It's just because some spots have energy, some spots doesn't. Should expect some more energy to reach, and we should see another increase in the temperature. As for Earth, Earth should start increasing in temperature anytime now due to energy and solar radiation. And really we should see Earth also evaporate into nothing. Venus, it's ranging really. It's going up and down between around 8,600. Oh, starting to increase the average. How's Earth doing? Earth has hit 36,000 degrees, so the energy has just struck our planet, and we should instantly really see the Earth turn to a ball of fire. So literally 1 minute later it's 15 degrees, and then a minute later it's 40,000 degrees. What? That would be scorching. Everything dead straight away. How's Mercury doing? How's our best friend Mercury doing? Mercury, oh my god. I don't even know. Let's turn this to Kelvin. Okay, so not very much difference at all, but that I believe is 98 million degrees Celsius. That's, Jesus Christ, that is so hot. Enough energy to wipe out anything. Even out here, look at this. The energy hasn't even got out to the outer space, and some asteroids and some other planets have increased in temperature already. Jupiter, as for Jupiter not so much just yet. Earth has hit 42,000 degrees. How's Venus doing? Venus ranging from 8,000 actually. I think that might be an in-game bug. As for Earth is decreasing in mass, no hope of living there, completely dead. I'm quite shocked that Mercury is, oh my god, that is unreadable temperature right there guys. If we fasten up the simulation, we should be able to see other planets and objects start to get affected. Ceres just hit 3,500. Mars, more towards 5,000, 4,000 between there. Earth, completely around the same as Venus, and same with Mars really. As for outer planets should start to see, yep, I just stopped Jupiter when it hit 4200 degrees, which is pretty hot for a gas giant in our atmosphere. Our atmosphere. In our solar system. Saturn is quite far away still, and it's reached 2700 degrees. Outer objects are starting to heat up. Not so much though. As for Uranus and all that, temperatures are increasing pretty quickly. It's kind of like a shockwave. So as time goes on, we should see pretty much everything in our solar system die from this colossal blast from our sun. Asteroids, however, are the only things that can survive this, because there's no atmosphere at all. Heat can't cause any effect, basically. As for Earth, 11,000 degrees at the moment. And we're just a ball of gas. Everything's a ball of gas. To prove this, let's say I put a new planet. Let's add a new planet. Let's go another Earth. Nearest thing orbitable is Jupiter. Let's add a Earth around Jupiter, shall we? It's actually bigger. And then see how straight away it just shrunk down? Literally in days shrunk down. Now let's see what happens in slow motion. Play. Look at it. Look at it. 23,000 degrees already. Instantly evaporated water. Of course the game can't render that stuff as quick as we would want. And now it's around 10,000. So it's basic. Nothing can really survive as long as it has an atmosphere. If it doesn't have an atmosphere, really, that's the only things that can survive. What happens if we add a sun into here though? Quite interesting question really. So let's add a sun with, let's add the biggest sun we can find, basically. Let's add 12 suns. Now the gravitational pull will affect all planets. Temperature wise, it's only 3,000 degrees. This is and that's Kelvin. Let's go Celsius. 3,200 degrees. Planets affected by the supernova, yeah, you know what I'm going to say, 10,000 degrees, 6,000 degrees, 8,000 degrees on average. Now the gravitational pull is going to drag pretty much everything back towards it. Earth, gone. Asteroids, gone. Everything, gone. Other planets, not so much. They're gone. They are gone. Pluto, the remnants asteroid. Neptune, yeah, has the mass of a moon, right? 15 moons. Could we survive on that? Probably. It looks like a black hole though, doesn't it? Because there's no light transmitting off it, apart from the sun I just set up over here. So guys, that is the effects of a supernova. I hope you guys enjoyed this video. Thank you very much for watching. Remember to subscribe for more content. Twitter and Instagram links in the description. And I'll see you guys in the next one.